That's okay. You'll hear it again. All right, you guys. So 3-2B, residuals and the least squares regression line. So we talked about the line of best fit, also known as the least squares regression line. We talked about interpreting slope and interpreting the Y-intercept. Okay. So residuals and the least squares regression line. So this is that Ford F-150 data. And basically the residual is the distance from the actual price to the predicted price. So the red dot right here is the actual price, which we got from like our data, right? You have a table and you plot the points, right? That's the actual price of the truck that they sold it for. And then what this point is this would be the predicted price for a truck driven about whatever that is, 35,000 miles, okay? So anytime you're doing a residual, it's the distance from the actual to the predicted. So the formula for residual is AP. Get it? Like AP statistics. That's how you remember. Actual minus predicted. Also, this Y represents the actual Y, your actual output, minus the Y with the hat on it is the predicted Y. So that's like the formula for it. And the definition is the difference between an observed value of the response variable and the value predicted by the regression line. Those are called residuals. All right, how much is that truck worth? Find and interpret the residual for the Ford F-150 that had 70,583 miles driven and a price of $21,994. So we plug in 70,583 and we're going to get a predicted price. This right here is the actual price. Okay, that's the coordinate point. So the first thing we need to do is plug it into our formula, and we found the formula last time, and it is price with the hat on it, predicted, and we got 38,257 minus 0.1629 times the number of miles on the car. By the way, we had to learn how to interpret y-intercept and slope. Quick review, what does this y-intercept represent? Yeah. Yeah. Good. When your X value is 0, when you have 0 miles driven, that's the predicted price of the truck, a brand new truck, okay? And then we have our slope, which is what you're talking about. For every 1 mile driven on the truck, the price, and it's always the predicted price, decreases by about 16 cents. Okay, that's the formula or the sentence for slope that you got to know how to do. Anyways, I want to find the residual, so I'm going to plug into this equation 70,583. So what's the predicted price if I've got about 70,000 miles on my truck? And we end up getting $26,759. Okay, that's the predicted price. So always interpret in context of the problem, address both. So we still need to find the residual. Let's find the residual. Residual is equal to the actual minus the predicted. The actual is the one from the table. So 21,994. And I'm going to subtract what we predicted the truck to be worth, 26,000. And we get negative $4,765. And you might want to write down how we interpret this residual. So you got to address the distance, which is 4,765, and the direction of the air. So the actual price of the truck, was it lower than expected or higher than expected? Lower, okay? So we're going to write that down. The actual price of this truck is $4,765 lower than expected based on its mileage. So that was just one residual. So how do we find the least squares regression line? And you should write down the definition of what this is. So the least squares regression line of y on x is the line that makes the sum of the squared residuals as small as possible. So we're trying to put that line in the middle of the data so that when we add up every single residual squared, we get as small of a number as possible. So the smallest distance between the point and the line. So if we just added the residuals up, like every single one of those little distances away, we would get something really close to 0, and they would just cancel each other out, which doesn't help us find that. That's why they square all those distances to get rid of the negatives, okay? So they're squaring all the distances and finding the smallest number. That gives you the best fit line. That's how they do it. You're not going to have to do it very often because your calculator is going to do it for you. I know we did this last week, but we're going to have to do this anyways to find what's called the residual plot. Plus, if you were gone, we can practice doing this. So we're going to make a scatter plot, find the least squares regression line, and then add something to it. So everybody grab a calculator. Mine are actually over here. I moved them because they're all charging. So grab one. All right. So the first thing we're going to do is make a scatter plot. So you're going to press Control Doc right here, or Control plus a page. And then go to Add Data and Statistics. And move your cursor down here to the x-axis. And you're going to plug in points for the x-axis. And move your data or your cursor over here to the x-axis, and you're going to put wins in. And you get a scatter plot. Okay, looks like a strong, positive linear correlation between points and wins. All right, then you guys go to Menu and go to Analyze and go to Regression, and we're going to do Show Linear A plus BX. A is the y-intercept, B is the slope. So we have a y-intercept of -3. Meaning if they scored 0 points, they have -3 losses, which doesn't even make sense, right? Sometimes it won't make sense, so don't really talk about it then. And we've got our slope of 0.44 right here, which means for every, 1 point increase in the game score, that the number of wins increases by 0.44. Okay, let's all review. All right, so you have to do this part in order to do the next part, which is called a residual plot, and we are going to talk about what that is. So, determining whether a linear model is appropriate. Do you guys remember how we assessed normality with what was called a normal probability plot? This is kind of a similar concept, okay? So in order to determine if a linear model is appropriate, we can use what's called a residual plot. So remember that the R value being close to 1 or -1 does not necessarily indicate a linear pattern. I always said look at the scatter plot. You can also look at the residual plot. What is the residual plot? Well, the residual plot is going to take the distance away, your x value, and the distance away, and plot it. So it's going to have on the x-axis whatever your x is talking about. So in this case, miles driven. The y-axis is the residual. In other words, this point right here is really close to its prediction. It's just a little bit above, right? And this point right here is really far above what its predicted value would be. That's what a residual plot is. Okay, the main thing you need to know about a residual plot, though, is if there's no leftover pattern, a linear model is appropriate. Write that down. Okay, if you've got random scatter, which is what this graph has, okay, there's no leftover pattern, that's the wording that you use for random scatter, then a linear model is appropriate. So we're going to make a residual plot on our calculator. You have to always do this first, and you have to have this line of best fit in order to find the residual plot. So everybody go to Menu, and then go to Analyze, and then go to Residuals, and then go to Show Residual Plot. And it just puts this little graph down here on your half screen. Okay, is that random scatter? Yes. So you would write the sentence, there's no leftover pattern, therefore a linear model is appropriate. When it says a linear model is appropriate, it's talking about this line of best fit. You can use it. That's the model we're talking about, just that equation, okay? It's allowed. So here's an example of when you wouldn't use a linear model. So is there a pattern in the residual plot? Yeah. Is there a pattern in the residual plot? Yes. You want random scatter, okay? If there's a pattern, then don't use the linear model. Usually there's random scatter, all right, on most of the problems, because then you can carry forward with the math. So when an obvious pattern exists in the residual plot, the model we're using is not appropriate. Here's how you do it in case you guys forget. I don't know if you want to add that in your notes. Menu, Analyze, Residual, so Show Residual Plot, just for what buttons to push if you forgot. No one has the 84, so we're good. And actually, I do want you to write one thing down, because people confuse these two things. So just a reminder about the difference. Normal probability plot. That's when you plot a bunch of points against their z-scores. If it's linear, roughly linear, you assume normality. Right? We also talked about if it goes like this and then it starts skewing off, that would be like a skewed right graph, so you cannot assume normality. That's the difference in these graphs, okay? They're totally different things. So when you're looking at scatter plot and assessing normality, you use what's called a residual plot. All right, and here's your guys' homework.